It's Gadget UK here again, back with another Neo Geo. This is a 4-slot. It was described as having some graphical issues and the top shielding being corroded. Now, in the photos for the advert, there was no pictures of the shielding, so I suspected it was pretty bad. I'll show you that in a sec. But the first thing I'm going to do is I'll just power this up. I've removed the screws here actually and stuck the diagnostics ROM in there in advance. I've inspected the board. I'll show you there's a bodge wire underneath on one of the potentiometers actually for the volume, which is a bit strange. But I don't see any of the damage. It just looks really dirty. It's got the original battery on, I'll show you in a sec, but in fact I can take this top board off because I'm going to boot it without this. You can see some corrosion there, and that just corresponds with one of these decoupling caps here actually. So it looks okay actually. It doesn't look like we've got any damage. It just needs cleaning up. I don't think there's any actual damage there. There may be a problem with the top board, I don't know, but I'm going to test it independently. We'll do that last. Got the diagnostics ROM on there. You can see the battery. So it's corroded. It's like rust on top of it, but it doesn't look like it's leaked. The board is a little bit weathered. You know, some of the pins look like they've suffered a bit of not corrosion of the battery, but corrosion from the elements. You know, it's just been sat in a really damp environment. This, and the shielding is testament to that. I'll show you if we have a look at the shielding in a sec. You know, the underneath of the board here, it looks okay. It's a bit dirty. We've got some questionable connections there. I'll check those in a minute. I don't think you can just about see that. It's like a brownie sort of appearance to some connections there, so that might be worth checking. I don't see anything else apart from dirt on here, but we do have this bodge wire here, and it just goes from one side of the, I think it's the ground on the pot, to the other. Can you see that really fudgely stuck on there? So I'm not really sure what that was trying to achieve, because I don't see any damage on either side there. It's a bit strange to say the least. Anyway, we'll connect this up now, and I'll just show you what it's doing. So we're all connected up with the 80X power supply and the supergun there, connected via SCART for RGB. Got the diagnostics ROM in there. Bear in mind it's stood off the carpet on its feet. I'll switch it on, and you'll see we either get a solid colour like this, but if you leave it long enough, do you see some text there? And if you switch it off and on, you can actually get some diagnostic information up. Initially it was coming up with WRAM bad, I think, and then it was backup BRAM, you know, backup RAM. So it's like we've got some contention somewhere, you know, there's a number of things being enabled when there shouldn't be. I think that's what's going on here. It's a chip select type or an output enable type problem. See that? So I think, there you go. So look at that, BRAM dead, output upper. But that's not consistent, you can get WRAM. So the interesting thing is, when we get a solid display like that there, that tells me a number of things. Some of the clocks are there. You know, there's a clock that would normally come from the D0 on the newer boards, that if that clock's missing, you won't get the text here like this. But there are other clocks, you know, we might be having a clock problem on something else, hence those pixels and things in the background, but I don't think so. I think it's things are overlapping, you know, like the CPU's trying to say, I don't know, read from ROM, and that seems to be working okay, but when it comes to accessing RAM, the BRAM and the work RAM, it's like for some reason that seems to be where it's falling short. It's like something else is enabled at the same time, and it may well be something to do with the graphics side of things. So I guess, you know, I mean, I was going to say look at the schematics and try and understand what might be a cause here, but there are no schematics for this, and because it uses the Pro chipset, that's the other complication. But we have got the pinouts, you know, I've had a quick look at the pinouts in advance. What I do know is the Pro C0, I think, is responsible for some of the address decoding related to perhaps the WRAM and the BRAM. I'm not sure. I think I see some SRAM pinouts there, which I'm not sure which they relate to actually. I mean, there is a HDC32 on here as well, which will be used just the same, and there's probably going to be a 259. But I just find it interesting that when it's wound up just a little bit, you can get this kind of behaviour here, and it'll toggle between BRAM and WRAM. Now, I'm sure that's a red herring in the sense that it's not the RAM that's the fault. And in fact, if I probe the HC32, I just see highs. And here's the shell. Oh my god, look how rusted that is. It's ridiculous. It's really thick rust. Look over here, it's black. Yeah, I'm amazed this Neo Geo even powers up, to be honest. Just look, it's horrendous. It's not so bad on this side. There's just little bits on the overhangs of where the slot edges are, and a little bit down there. But yeah, it's going to take an incredible amount of work to clean that up. A couple of ideas spring to mind. Electrolysis is one of them, actually. You know, I could get a tank, fill it up with, I'm trying to think what you use, water, and is it baking soda? I forget, it might be bicarbonate of soda. I always get those two things mixed up. There might be one of them the same, I'm not sure. And then you need some rebar or something, some bits of, presumably I don't know what it's coated with. Anyway, it's a piece of metal. I'm not that up on electrolysis, and you connect a positive to one side to one of those probes, I think, that goes into the tank, and then the other goes onto here. I think the negative goes onto this. I could be wrong. And then the rust will just come off. It might take several hours or more, but yeah, the electricity going through there will pull the rust off it effectively. You could then coat it with zinc or something like that. One of my subscribers suggested a similar thing actually recently on one of my videos. I don't think I've got the time and energy to go about doing something like that, although that might be the easiest solution. I might just try a chemical rust remover first of all on this, see how much of that it removes, and then sand it down, you know, just get a sander onto it with a fairly fine grit. I'm not sure. I'll just check the pin out of that. I can never remember whether it's output, input, import, or whether it's input, input, output. Because the difference there is if that's an input and it's low, that's an input that's high, it's an OR gate, so it would be high on the output, that would be correct. But if this is the output, you've got two highs, it should be a high. I'll just double check that, but yeah, if it's not that, I'm not sure. I mean, the other things spring to mind to do with the address decoding, maybe the ROM's enabled at the wrong time, maybe it's these 05. Now you've got the battery here, this was the problem I had with the 6 slot, maybe we've got a damage trace to that 05 there. One of the things that makes these difficult, because they're open collector outputs, you can see like that's the VCC, there you go, we've got a pin there pulsing, but the pin next to it is low, and this is an inverter. So you're like, well, how the hell do we go from pulsing to low, or from low to pulsing? And it's the same as you go along. If we go to the next pin, you've got pulsing, a low, a low, and a low. And that's the interesting thing there, a low and a low. How do you get that? I think it's a case of an open collector. I can't test using this logic probe, that's how it seems to be. So on this side we've got a low and a low, that's strange. Pulsing and a low, that's strange. They're all strange. So I think the next thing we'll do, just based on probability, is remove this battery and just clean up with some IPA and cotton buds around this area here and just inspect super close. So I'll just tip a bit of IPA on here actually to leak underneath there, and if we just leave that for a few seconds and then just try and gradually lift this off, it should hopefully start to peel. Yeah, hopefully you can see that, it's just gradually starting to move. Yeah, it's leaving some of the black stuff behind. Sometimes it comes off one piece, sometimes it just disintegrates, and in this case it's just disintegrating. What a pain. You could try and heat it. You can see some of it's come off there. I absolutely hate this stuff, because now I've got to dig around and try and find the blooming battery terminals. The crazy thing is, I've been removing this for a minute or so now and I still don't see any battery terminals. So where are there? Is that one? Yeah, I think that might be one there. Yeah, and the other one's over here. So there we go, we can actually see them now. Yeah, I can clean this up afterwards, I just want to get to the darn contact. So I've adjusted the camera a little bit there because there's a lot of light glare actually, and we'll just get onto those contacts. I think I'm going to try and pull the battery although it's glued a little bit on the other side actually. There we go, just try and free it up. Yeah, so I'm just pulling the battery from the other side a little bit as I heat this. Yeah, there we go, that should come off now I think. Just going to pour a little bit of IPA onto the edge there, just try and get it into that glue actually. There we go. And we could just carefully try and lift this. It's one side off. We'll just apply a little bit of heat from this side here as we just remove this. There we go. Yeah, so I'm not seeing any corrosion actually. I mean, the battery's corroded, as you can see it's rusted on top there, but the board looks alright. But anyway, I'll remove these pieces of glue and we'll clean up with some IPA and cotton buds. So with the controller, if I press select and start, I can reset it. Now that shows me a number of things. It shows me that probably the data bus is not compromised here. Well, you know, the fact that ROM booting is a good example of that, but what I mean is, if you think back to the MV1As, you could sometimes get things like this when you had a data bus problem, and you'd find it would just not, it would hang, you know, that at this point here you wouldn't get controls and things like this if you had a data bus fault. But the fact that, you know, you can consistently reset this makes me think the data bus is not the problem here. It's interesting how it seems to get a little bit better as it gets a bit warmer, this actually. I don't know if you noticed that, we've got some corruptions at the top there, but anyway, if we hold down A, B, C, D, this is another clue, and then press select to start, it's watchdogging, it won't boot. And that could be a number of things. I've seen that behaviour before when the WRAM is not accessible. You can't get into the A, B, C, D menu, you know, the menu of all the tests here, when your WRAM is not there. You know, you're not able to access your WRAM. Now initially I did see the same error we're seeing here, or a similar one. I think it might be the write failure or something on the WRAM. But the fact this seems to be going on about the WRAM and the BRAM predominantly, ignore the graphical issue. It's going to be something in common with the two, and maybe the graphics as well. So in the first instance I might just swap out the HC32 actually. Maybe it's just something as simple as that. I mean, it's a bit strange. The graphical thing leads me to think something more going on with this actually. Can we test any of the other modes by holding directions and things? No, we can't. Yeah, so we're not going to get any further until we can access the WRAM there in terms of diagnostics. So the interesting thing is it didn't need to warm up there actually. Still got the same fault with the graphical issues on going on about the BRAM. But if I feel that chip there, that's actually quite warm. That's just lukewarm. Cold, cold, cold. These are all cold. That one there's warm. I'm wondering if this is outputting what it shouldn't be doing, which is maybe clashing with the WRAM. I mean, it's entirely possible this has got a WRAM fault, a backup RAM fault, and some other fault. That's not out there as a possibility. I think I'm just going to remove this IC here actually, just based on the fact it's warm. You know, you've got to question, why would that one be warm and that one be stone cold? Same manufacturer. Those are the backup RAMs as far as I understand. And these are stone cold. Yeah, I'm thinking maybe that is causing us one issue here. So let's remove that with a hot air. So this is with the BRAM removed. You can see it's gone on to WRAM now. I am wondering actually, there's a couple of possibilities. It could be that the, you know, like I said, the chip selects output labels and stuff are wrong on these chips. But it could also be that the RAM's failed. And it could be that the same type as RAM has failed. So, you know, these are all the same manufacturer right down the side of the board there. It could be we've got a failure on the backup RAM, a failure on the work RAM, and a failure on the video RAM. I mean, it's unlikely, but that's what I'm thinking. I'm thinking those lines may well be VRAM related. But because we can't get past these first initial 2 tests, we're not getting to the stage where it goes, you know, oh, you've got a VRAM failure. It's interesting how it's not gone on at the backup RAM now it's moved on to the work RAM. But you see, this is how it was originally, so yeah, I'm not going to read too much into that. But what I'm going to do now is remove the lower WRAM and swap that over, I think. So the next thing to do is work out which one it is. It's saying it's the lower, so we're looking at bits D0 to D7. So if I compare to, if I look at the 27C1024 pin out for the ROM there, I can just do some connectivity tests and work out which one, say, got D0, which is the lower, and we can just remove and swap the lower chip, just see if that makes any difference. Yeah, so looking at the ROM pin out there, the 27C1024, you can see Q, this is the data bus, instead of D whatever, it's Q whatever. So yeah, Q0 is down here, pin 19. So I'll just measure from pin 19, and we'll just measure around the 2 SRAMs there, I'll show you that, work out which one it is. So this is a 40 pin device, pin 1's down here, pin 19 is up here. So we're on pin 19, and so we're on pin 19, and we can just measure around here. I forget which side the data bus is on these. Yeah, it's that one. Yeah, so that one's the lower. So as you look at these boards from the other way up, the lower chip is the lower, if that makes sense. So that's the lower, that's the upper, that's the lower, that's the upper. So we'll remove that chip next. So I've scoped the address lines, and I'll show you in a minute actually that A1, A2, A3 and A5 look really strange. They're super low level. So there's something going on somewhere. Now, from memory, I think some of the Pro chips over here, I think that's got connections on our A1, A2, A3, A4. I'm not sure about A5. There are other things going on here. The other thought, coming back to, you know, we've ruled out these, you know, because it mentioned the work RAM. We swapped the lower work RAM, and then it mentioned the upper BRAM. We're not getting anywhere with that. I'm pretty sure those chips are okay. The output enables go directly from these 4 chips here to the Pro C0. I've confirmed that on my multimeter. So potentially we could have a faulty Pro C0, but I'm thinking this is a bit like the 6-slot fault we had, where this is perhaps not getting something it needs in terms of addressing the ROM here, you know, with the output enable. So maybe this ROM is enabled at the same time as it's trying to do other things, i.e. read and write from the RAM here and the video. That could clash with everything. If this ROM is enabled at various points when it shouldn't be doing, it could be clashing with all sorts of reads on the board here and writes on the board. I still think it could be this that's faulty, but I'm thinking back to these 05s that we had in the previous video here to do with the initial vector assignment there of the 0 to FF address ranges, I think. So there's 3 chips, there's 3 of these LS05s, and they're inverters, but the open output, open collector outputs. So I think I'm going to start with the one over here nearest the battery, and I'm going to remove that, socket it up, and we'll just try a replacement one. That is where some of the dodgy address lines go to. I doubt it's going to be that, but one of the problems you get is trying to test these 05s with a logic probe. The outputs, I think, are all joined together, so you've got like multiple of them from the 3 or 4 chips that are there, all going to one of the pins on the XOR here. So when you try and make sense of whether you're getting the right output according to the input, you can't make sense of it, actually. Do you see what I mean? It's like all the inputs are various states at various points, and the output is a reflection of all of them, which, yeah, makes it damn near impossible to trace it that way. The only way you could do it really is with a logic analyzer and all the address bits, and then on the outputs of this XOR here to see if you're getting the right result coming through the XOR, I guess. But that's just painful. I haven't got time to be doing that. So yeah, we'll remove the 05 here, then we'll just work through the other 2 or 3. I think there's 3 in total, 3 chips, because you've got 6 gates on each one. Yeah, I think that should be enough address bits for the bits that are used there. So I'm not really getting anywhere fast with this. I'll show you this diagram here that Furtek did. So this is the address decoding here that we used on a previous repair, actually, the MV6 actually. This came from Furtek. And what's going on here, you've got all, a number of address lines all going to these 74 LSO5s, which is just an inverter with an open collector output. And all of the outputs all join together and go into an XOR here, and this feeds some of the some connections that I think ultimately lead to the Pro C0 down here. And that basically is enabling the output enable here via some logic somewhere. There's an AND gate or something. Yeah, so the output enable, the top right there. Now that is pulsing, and you know, if we didn't have some activity there, it wouldn't be booting. But you know, I can't help but wonder if something's going on here. So you know, I've swapped out the 05. Sorry, it's that one there. Socketed that one up. It's just the same. We swapped out the HC32 previously. I didn't think that would be relevant, but it was just worth it because these are the things that can sometimes fail in that area around the battery there. So I've still got 2 of those to do. Measuring with a logic probe, it's near impossible to tell whether they're working or not. Because, well, for one thing, all these here are joined together. Unless one of these was outputting a high one, it shouldn't be doing, but still, it can be quite hard to test those actually. So yeah, that's my thoughts. I'm thinking it could be one of those 2. It could be the XOR here. Now it's not that we're not getting no activity at all on the output enable. Otherwise, let's say it wouldn't be booting. But I'm just wondering if one address bit is occasionally flipping state when it shouldn't be doing through the 05s, which means that the ROM is enabled or disabled at the wrong times. But thinking about it, I'm not sure it would boot properly if that was the case. So I don't know. I mean, trying to explain here, these are some of the thoughts I'm having while I'm thinking about this. The other thing is, I've got the controller plugged in down here, and if I go into the diagnostics, I can't hold down ABCD because I think obviously we've got a problem with the output enables on the WRAM and the backup RAM there. Now, I previously swapped those 2 chips. I think it was a red herring that's complaining about those chips being faulty. It is all about the output enable. Now, the output enables come from here, so it could still be this faulty. But other things I'm thinking, do we have a data bus fault? Well, I don't think so, because you can hold down select and start and you can reset it. That works. Now, the way that works is this chip here, it does some Z80 arbitration, but also I think the Pro B0 here, the controllers read through this as well. And the way that works is there's going to be a data bus connection somewhere around here to the 68K. So the 68K, when it needs to read the controller inputs, that's what it does. It uses this to, read the controls through to the data bus on the CPU. So if we had a data bus fault, that wouldn't work reliably. You wouldn't, be able to press select and start and have it reset. And that works really super reliably. So I don't think we've got a data bus fault. I removed this chip down here because I thought it had some low address line levels, but actually in retrospect I think what's happening at the point when it comes up with the error, only certain addresses are being read. I think like 3 or 4 address bits were low, and that confused me and led me towards thinking maybe we had something affecting the addressing. But I don't think so. I mean, there might still be. There's a number of things around here. There's some more 244s I can remove. And coming back to what I talked about in the previous video, the divide and conquer, I could do that. I could remove some of these 244s down here and the 245s, just pull them off and see whether we've got any difference in behaviour. Because these 244s are going to be for feeding address connections to the top board, the cart PCB. The 245s are going to be for isolating, gating access to these things at the back here, the connectors at the back for the memory cards. So we've still got 2 chips we can rule out there. I might just do that next anyway, because I've got nothing else to go on here. If I had a professional, and I'm saying the same things I always say, if I had a professional logic analyzer, I don't know, a 64 channel one or something, I could connect it up to the address bus and the data bus and just do a full capture, and then trying to understand what's going on. And it would take me quite a while to do that actually. Just looking at the addressing in particular to see what gets addressed. I mean, in theory, I could, I could use in my logic analyzer capture the output enables of various things. It's 16 channels, so I've got quite a lot of output enables I could capture. And see what's happening. Have we got things enabled at the same time? I think we have. I think we know the answer to that already. The fact that we're getting some graphical issues, so this is another clue here, the graphical stuff going on, at the same time as the RAM problem leads me to think that there is something going on with the address decoding somewhere that means that it's trying to access the RAM, and actually it's getting the video. You know, that could be why we're getting like pixels and lines and weird things going on, because it thinks it's trying to write here, and actually that isn't enabled because something somewhere has not enabled that. Well, we know this enables the RAM, but maybe this is enabling something else. It could be a missing address line to this chip here. Again, it could be a fault with this chip here. But there are other things, you know. I was looking at this connection here, the VEC signal. Now, I did have a look at the memory map for the 68K on the Neo Geo, and I'm not completely convinced it could be related. But I'm just wondering if there was an issue here where this was not a reliable signal, the VEC signal. And this comes from, I traced it, the 259 down here, I forget where it is it that one there? I think it is. So I could socket up that, but would that cause the problem? Well, it might do, because if that was outputting at the incorrect time, the net result is, because all these outputs are joined together, it could enable the ROM. So it may well be that the ROM is enabled at the point when we're trying to do something with RAM. I mean, I know it's a long shot. The frustrating thing is I haven't seen any activity on the output enables here, you know, and that's the problem it's complaining about. It's saying that the, you know, dead output. Again, that comes back to, is this faulty? So other thoughts, well, the D0 stuff is replicated here, well, some of it, the clock generation stuff as far as I can see. You've got a 161, a 74, 74 here, I think. Is that an LS86? I can't quite see the part number, it's upside down, I think it is. But nevertheless, some of the components around here, I think, are used for the clock generation. Now, I have off-camera checked the clocks on the Pro C0, the Pro B0 and the LSPC. I think there's some clock inputs on those there. And I've got clocks, so it's not like we're missing a clock. But what could be happening, we might have an out-of-phase clock. So, you know, one clock is, instead of being where the edge being where it should be, it's a cycle or two to the side. Maybe with respect to the video side of things. So maybe the video stuff is kicking in when it shouldn't be doing it. I don't know, because I don't understand fully exactly how one of these systems works. I'm not an absolute guru at these. Someone like Furtech might go, actually, from the symptoms I'm seeing here, I would speculate it could be X, you know, or Y or Z or whatever. I've not got a massive experience on these systems. I've only got the experience that you've seen within my channel, really. Now, we can rule out, I think, the palettes being enabled at the wrong time, because I don't see any colour issues. We've got some coloured blocks, but I don't think we're in the realms of looking at a palette thing, you know, with the graphics, talking about the graphics issue now. What could be going on is something to do with the output enables on these, but I think, from memory, it comes from the LSPC. So, you know, there's a question there at the moment with the graphics side of things. Why would the graphics be, you know, interfered with? Could we have a fault with the LSPC here? Or, again, is it the backbone addressing here, or clocks, that means that, you know, this is receiving, you know, writes from the CPU when something else should be receiving writes from the CPU, e.g. the RAM, or something like that? I don't know. There's one final piece of the puzzle here I'll show you now that again is a clue. I'm not really sure what to do with all of these clues to piece them together actually at this stage. You know, I've mentioned a lot of things I could look at here and swap out. I'm reluctant to do that just now. I think the next thing I'll perhaps do is check all the address lines on the Pro C0 actually, just to make sure that's got everything it needs. I then may move on to the LSPC and the B0, is it a B0? Yeah, Pro B0, just to make sure they've got the right address lines, because a missing address line somewhere could also explain what is going on. But I'll just show you the other symptom now, hang on. Yeah, so our final clue now, and this might be a big clue, I honestly don't know how to interpret this at this stage, but just watch this. I'll switch it on, right, it's cold. Watch what we get, a solid colour. Switch it off and on, see what we get. A solid colour. Now this is consistent. This happens if you just do this when it's cold. you'll just get a solid colour. But you just leave it for a minute or two, and I've got the controller connected here, I can reset it, so you can see the reset occurring there. So we know we've not got a data bus fault. You know, that's a big clue to me that the data bus is not like constantly being, you know, one pin being affected when it shouldn't be doing, because I can reset it. But as this warms up over about 60 seconds to, I don't know, 2 minutes, 1 to 2 minutes, you'll see it will start to work. Let's just try a power cycle. Usually it's after a power cycle it does it. Still got solid colour, but it's very cold in here just now. Yeah, so I don't know if you can see that. I was holding down to ABCD and letting it do a constant reboot like that, just for, I don't know, a minute. And then it's up. You know, we've got these graphic issues, as you can see, and they get better again as it warms up. So whatever the issue is, seems to be temperature related as well. Now, initially I was thinking maybe a bad wire or something. As it's warming up, it's working. But the board is not. I would say the actual PCB hasn't got warmed up. You know, it's got to be actually an IC that is causing that behaviour. But nothing is warm on the board. Well, there's a couple of 245s that are just lukewarm after a few minutes, but they're not super hot. And in fact, I felt them, you know, on that 6 slot I was looking at, and they were even hotter on that when those were okay. So, yeah, I'm not sure what clue that provides me. My freezer spray has just run out, so I can't even use freezer spray to determine anything either. BRAM dead output upper. So, you know, we're consistently stuck on that now. It's interesting now at various points we've had a WRAM issue. So I think while I have a browse of the schematics for the MV1F and just have a think about this in general, about what I'm going to do next, I might just leave this on. In fact, you know, I'm leaving it on now, it's powered up now, and I'll just show you. That's 30 seconds later. Can you see? The graphics issue's actually a lot better. It gets better over time. Let me just reset. You'll go crazy again. But that's a lot better. It gets better with time. So, yeah, and there could be 2 faults here. You know, that could be the thing that's throwing me here. Yeah, we might have a temperature-related graphics issue there or something, as well as this other fault. But I think I'm going to leave it. I'm going to leave it powered up for half an hour, and I'm just going to watch it and keep checking temperatures and things, just have a feel around. Maybe something will fail, you know, as long as it's not one of the main 3 custom chips. I'm quite happy for something to fail completely, because that would be better than the situation I'm in where I'm just getting crazy behaviour. So I printed off the pinout here of the Neo Pro C0 from the Neo Geo wiki. I'll stick some links below. Check the address lines up here and here, and I've checked UDS, LDS, DTAC, the cert pin AS, read write, all to the CPU. All connectivity there is good. I mean, there's still other things around here that might be relevant. You know, we could have some bad connections on other things around here that might be causing the behaviour, but yeah, I mean, the obvious stuff's okay. Like I say, and I've checked these pink ones here, the clocks. I do see clocks, so it's not like we've got a missing clock. But obviously, I've not checked them side by side, so we could have a timing issue there where one clock's, edge is not in the right place, effectively. So, where next? Let's try switching it off and on to see if we get any graphical issues there. No, you see it comes straight back on. Super interesting. I mean, even if I could get rid of these lines at the top there, I'd feel a bit more positive. What might be going on is we might have a VRAM failure as well on this board, and that's what we're seeing there, actually. I'm not sure what type of VRAM would be responsible for those character positions and stuff there. Is it the 62256s? So I found if I heat the SRAM here, the video, just watch what happens. So bear in mind, I'm only going to heat this for a few seconds. I'm just waiting for it to get up to temperature. Hang on a sec. And then I'll put it over the chip. Right, so the hot air is hot enough. And just watch what happens. It's not doing it now. Oh, there you go. Can you see that? And that is the behaviour we were getting. So I would suggest that the VRAM is faulty as well on this, which, you know, I thought as much. I think what's happened here is all of the RAM on that whole side there has failed. Oh, I've just realised I made a critical mistake when I was testing which was the upper BRAM and which was the lower BRAM. This one is the upper BRAM, and I know that because I've just tested from, like, I don't know, you can't see it down here on the CPU here. Let me just move the camera a little bit. Somewhere around here you've got like D12 or D13, and lo and behold it lands on this chip here, up here. So we may, the Pro C0 may be okay. I'm going to swap that next. I suspect we might get past the backup RAM error. Then I think we're going to have a work RAM error. And I think when we've resolved the work RAM error, we're going to end up with a VRAM error. I think this whole block of SRAM here has failed. I think that is what is wrong with this board, actually. I'm really annoyed with myself, but with my multiple chemical sensitivity and chronic fatigue, I'm just having the toughest of times at the moment, actually. I find it very difficult, which is why I've not had very many videos up recently. Hang on. So we'll get this chip off there, and I'll get a replacement on. We'll see what happens from that point on. I think this might resolve the backup RAM problem. Now, you see, the mistake I made, and the reason I started hunting in other areas around the board, is because I couldn't see any activity on the output enable on the BRAM. Now, there might be a reason for that. You're looking on a scope. The problem with diagnostics, like the SNK diagram here, it enables the output enable and it reads some values and probably fails very, very quickly. So, and then it switches the output enable back off again, which it needs to do in order to address other things in the system. So it's not like, and this is where I think there's a deficiency in some of these test ROMs. What would be better is when it fails, continue to retest the thing that failed. Still display the message, but just keep going around in a loop, just keep testing it, keep displaying the message, because if you do that, you'll see pulsing on the output enable. But because I think the way it's been written, and I could be wrong, but this will be a good indication, if we swap this and it passes, we know that is the case. I might just suggest to SNK Dan that you could make that mod. I don't know whether the ROM source, is open source or what. But this is the problem. I was even contemplating writing my own little NOP generator ROM, if you like. You probably don't even need a ROM, you could just hardwire the data bus in order to just cycle through the address bus, if anything, because that would perhaps reveal something as well, although the watchdog would keep resetting the damn system. That's the problem there, I think. I'm at a distance here, it's proving quite fiddly to do this on camera. There we go. But then the next port of call will probably be, possibly, the WRAM. We might get a faulty WRAM, and I'm guessing it's going to be the lower one. And then beyond that, the VRAM. I'm pretty certain we've got a VRAM issue here, just because, that whole technique of heating here seemed to get the system working. Oh my god, yeah, there we go. That's what I wanted to see. I am so pleased, because this means the Pro C0 is not faulty. Despite the fact I couldn't see any activity on the output enables there, I suspect, well, I know for a fact, if I'd got my logic analyzer onto it, I would have seen some activity. And this is the issue when sometimes we're using a logic probe or a scope, unless you've got a modern scope that's got capture, you can't always see, or some sort of trigger where it'll capture on a trigger. My scope won't do that, it'll just show in real time what's going on. So, the only time I would see an output enable, switch the power off, switch the power on, bang. If I've not been watching it for that 1 nanosecond or a number of nanoseconds where the output enable is in the other state, I can't see it. The transition's so quick there. So, yeah, this is very positive. So, it looks like the WRAM's faulty, as I suspected. So, we can, if looking at the value there, actual 0100, expected 0000. So, let me think about this. The upper WRAM has got. It'd be helpful if it told you that, actually. I know that's another improvement I would do to this. If you've got a fault there, tell me whether it's in the upper or lower or both. But anyway, yeah, that's the upper BRAM, which on the board from the front is going to be the lower chip. So like we've just swapped the lower chip for the BRAM, and that's actually the upper BRAM. So it'll be easy to work out which one to swap over for the WRAM now. But we're making some progress, and the reason why when you hold down A, B, C, D, it doesn't go into the menu there is because it needs the WRAM. That was one thing I've learned through the different MVS boards I've worked on here. Without WRAM, you cannot get into the diagnostics menu at all. It'll just do that. You know, if you hold down A, B, C, D, it just resets. And as we talked about earlier, the graphical issues there, that's the VRAM. That'll be the next issue once we get past the WRAM. So after a quick swap of the WRAM, the one I already replaced there, we've got the same error. Now it is the upper word there. So I think I'm pretty sure I've targeted the correct chip. That is the upper. I mean, I'll double check that, but I think I'm going to clean the flux off there, and I'm just going to do some connectivity tests just to make sure we've not got a missing data bit there, because we could have. Yeah, rookie mistake actually. I'm embarrassed about that. This was the upper BRAM, and if I test from the second pin from the left hand side there, that's the first data bit, and I was expecting to go here and it doesn't. It goes up here. So this is the upper WRAM, that is the lower WRAM. These are the opposite way round they are to up here. So like the upper's the first one, then you've got lower BRAM, lower WRAM, upper WRAM. So this was faulty originally, so we have swapped that out previously, but the chip that was in here a minute ago, and I've now swapped it for an Hitachi, that one's okay, but we need to swap this one out. So I'll put that one I've just took off here, there. That should be the WRAM and backup RAM, okay, I think. It's this bit at the top here that's confusing me. WRAM address. It's like it's an issue with the addressing rather than the chip. I'll just make sure that the address lines are all connected up to both those WRAMs. That's the first thing I'll do, because I don't want to be swapping these things needlessly, like I've been doing to a degree. But I think, yeah, the lower might need swapping as well, actually, even though despite we've swapped that, but it's one of questionable origin. Yeah, so all the address lines were connected up okay, and I've swapped it again. You can see now we've got the VRAM, which is what I expected. So yeah, let's do those ones next. But so the interesting thing here is, if we look at the values, let's see what's the upper or the lower. We've got an actual 55 expected, so that's the upper. Let's just see if we get any instances where the lower's a problem. Yeah, the lower matches there. Matches there. Matches there. I want to say lower. The way you read this is the first two hexadecimal characters there are the upper, and the two to the right are the lower. That's the way you go off this. And as I say, when you're looking at the actual relationship to the chips themselves, you know, on the data bus we were looking at before the CPU, you know, the 68K data bus, you've got D0 to D15. So D0 to D7, and that's the lower. That would go to the lower chip. So if you measure connectivity, say from, I don't know, D0 to the two backup RAM chips, D0 will only go to one of those two backup RAM chips, and the same is true of the WRAM. And of course, you know, the same is going to be true here. If you look at the pin out of the LSPC, it will have a 16-bit data bus, you know, D0. It might not be designated with a D, it might be P or something, but it's going to be 0 to 15, and 0 is going to connect to the lower, 15 is going to connect to the upper, you know. So that's how you can work it out, but it looks like just the one VRAM, and I suspect, I know which one it is, it's going to be the one I was heating, which is the one nearest the edge of the PCB actually. Yeah, I swapped out the one that I knew was definitely temperature related, and you can see that's given us a lot of progress there. You know, a lot of the graphical issues have come straight up, but we've still got an issue because the other SRAM has got an issue as well. That means that every single SRAM on there, both WRAMs, both BRAMs and both VRAMs will have been swapped out. So yeah, I'd swap that one with Liontech. I now need to swap the other one, which was less temperature sensitive, with Liontech as well. So I've swapped that other chip out with Liontech. Oh yes, sweet. So I've got the 244 reinstated there. It's just a shame I did some of the work with some of these 05s, because I was convinced in my mind that what we were seeing was something wrong with the address decoding for the ROM. But nevertheless, we got there in the end. It was only really after thinking things through again and thinking about the temperature issue, I thought we'll just clean this up here. Actually, it looks like just a bit of corrosion. I don't think it's actually done any damage whatsoever. We can inspect this a bit closer later, but yeah, I think we're going to be okay there. There's no traces or anything around that area. There's one here. Check that with a magnifier in a minute, and as I say, we can clean up more thoroughly there later. But let's just give this a go. Let's connect this up now and see what happens. So the first two slots I tried, I couldn't get anything after a few insertions and removals. Slot 3 gave me some weird graphics, so slot 4, it could just be the cart's dirty or the slot's dirty. I'm going to try and clean up the cart first of all. I can hear sound though. Let me just turn the volume up a bit. Yeah, that's good. Let's try slot 2 and slot 1. These didn't work at all previously. Yeah, some graphical issues there as well, look. Oh, but if I move the cart around, it starts to work. I think I'm going to spend a little bit of time cleaning these slots up because I think the slots are the issue here. So I folded some paper 4 times. As you can see, just flatten the edge down there. Get a bit of IPA on the edge. I need it near the edge actually, up here. Yeah, that'll do, sort of get it on both sides. And then do a bit of this. You can see how dirty that is there. So now we've got it working, I think the next step is to clean it up. So just to reconfirm here, that's the upper BRAM, lower BRAM, lower WRAM, upper WRAM. So it's interesting, let's say those two are joined together, those two are joined together in terms of the data bus. So cotton buds with the IPA to start with, and then I'll go over these with the toothbrush actually and some IPA, just to get in and out the gaps between the pins there. So I'll go over the wider areas of the board just with paper towel before we go with cotton buds into the smaller gaps between the chips and things. And we can go over the tops of the chips at this point as well. Yeah, so I cleaned those with vinegar and then Coca-Cola. I didn't have much vinegar. I mean, you can see the stuff's coming off that actually. You know, the corrosion has been removed. So I've cleaned the feet, but you can see the rust there. Wherever those little standoffs have been on here, we've got marks on the board as well, so I'm cleaning those up whilst I'm here before I stick the feet back on. But both the feet and the standoffs are super clean now. So sorry, it's a bit of an abrupt end to this video. I'll give you a little sneak peek of how it turned out at the end here. You wouldn't believe that this is the same system, believe it or not. A lot of work went into the cleanup work. This board actually is going to RiotRetroGaming, so if you watch their channel, you should see hopefully in future some Neo Geo gameplays over there. But I've had to split it into 2 videos because the next part, just finishing cleaning up the main board here, testing the board, you know, getting the cart slots working and stuff, and in particular the work on the shell, it's just leaking over too much. This video would be too long if I included everything in the first part. So the main thing I learned from this myself is Occam's razor, you know, the simplest explanation being the most likely. So if you think about the behaviour we were seeing right from the start, you know, backup RAM errors, work RAM errors, VRAM errors, you know, on different buses, the VRAM sits on a different data bus there to the work RAM and the backup RAM. The clue was there right from the start actually, you know, so if you get a problem like this where you've got multiple errors going on there all to do with the, you know, the looks like the RAM side of things, just swap the whole lot, blitz the whole 6 chips there, swap them all. But anyway, I do hope you found the video interesting. Please like, share and subscribe, and I'll catch you in the next video.